We're going to add some fog to the spinning cube program we saw earlier, and let me explain a little about the idea behind fog in OpenGL. Whenever we draw a pixel to the screen, we're going to average the color gray in with that pixel. And if the pixel is farther from the camera, we're going to assign a higher weighting to the color gray. If it's closer to the camera, we'll assign a lower weighting. So basically, pixels that are farther away will look more gray. And that'll give us the effect of making it look like we have fog in our scene. So I'm going to take the spinning cube program right here. This is the same as the spinning cube program. And I'm going to add some fog to it. So first of all, I'll go to init rendering and call GL-enable GL-fog to enable fog. Using a call to GL-clear-color, I'll change the background color to gray to match the fog. And that'll just make the scene look nicer. Then I'll go down to Draw Scene and put in some stuff over here. First of all, I want to indicate to OpenGL the color of the fog that we want. And I'll do that using an array of GL floats. You can actually have weird colored fog, like red or green or anything. But we're just going to have gray, which is 0.5, 0.5, 0.5. And the last element of this array will just be 1. Then we tell OpenGL that we want to use this array for our fog color by calling GL-fog-fv, GL-fog-color, fog color. So now OpenGL knows what color we want. There's one other important thing that we need, and that is a function which takes the distance of a pixel from the screen and maps it to a weighting for the gray color, a weighting that ranges from 0 to 1, or 100%. And OpenGL lets us use a few different functions, actually. And I have a graph right here of the functions that we'll be using in this program. So the x-axis of this graph is the distance of a pixel from the camera. The y-axis is the weighting assigned to the gray color. And we're going to try this linear function first. And this linear function starts off at 0 until it reaches some distance. Then it linearly climbs until it reaches a second distance, and then it stays at 1. So, in order to do this in OpenGL, we would call GL-fog-I, GL-fog-mode, GL-linear to indicate that we want a linear function. Then we have to tell OpenGL what these two distances are, in this case 10 and 20, that are important for this function. So we'll do that by calling GL-fog-f, GL-fog-start, and then the starting distance, then GL-fog-f, GL-fog-end, and then the ending distance. And this is basically what we need in order to have fog. Actually, I've been saying that OpenGL determines the distance of each pixel to the camera. Actually, it might approximate the fog effect by just computing the distance from each vertex to the camera, for instance. It depends on a bunch of different things. But I just thought you should know that. Anyway, if we run the program, this is what we have. It actually, I think, looks pretty nice. Looks like we have some fog. And points on the cube that are closer to the camera, like this right here, are less gray, and points that are farther away are more gray. So we have a nice looking fog effect. Now, let's see what happens if we use one of these other two functions, glexp or glexp2. So instead of having a start and an end distance, these actually use a different parameter called a density parameter. So first I'm going to switch this from GL-linear to GL-exp, and then I'm going to tell OpenGL what this density parameter will be. I'm going to comment out these two lines because the starting and ending parameters no longer have any meaning. And I'll call GL-fog-f, GL-fog-density, and then 0.05, that'll be our density. And if we have a density of 0.05, then this function right here will be equal to 1 minus e to the minus 0.05 times the distance. And that's how we get this function. Now, if we run the program, let's see what it looks like. Here we go. It still kind of looks like the fog effect, although for this particular scene, an exponential function doesn't work as well. There's not as much difference between the gray coloring of pixels that are close and pixels that are farther away? That's because if you look at this graph right here, most of our distances are going to lie within a small span of values right here, which means that the weightings for the gray color is going to lie within a small span of values. So we're not going to have that nice differentiation, that nice fog. So in this particular scene, the linear function works better than the exponential function, although in more complex scenes, in other scenes, exponential might work better. You just have to see what's best for your particular program. Now we're going to try this exp2, this square exponential function, and if the weighting of the gray color is y and the distance from the camera is x, then this function would be described by y equals 1 minus e to the minus open parentheses 0.05x close parentheses squared, 0.05 being the density. So if we want to use that function, we just change this from glexp to glexp2, and that's it. We'll just run the program and see how an exponential square looks on this particular program. And here it is. Kind of looks like we have fog, but the linear effect really did it. The linear function really did the fog effect best, so I'm going to switch back to linear because I thought it looked pretty nice, the linear function. So again, for this particular scene, linear works best. Other scenes, you might want to use one of the other functions. And anyway, that's how you can do fog in OpenGL.